Hello, everyone. Thank you for coming to the session. I'll try to make it fun. We're going to extend Kubernetes by writing a custom resource and a custom controller for it. And a little bit about myself. I'm originally from Eastern Europe, Belarus, so I speak Russian. 10 years ago, I moved to the United States, and now I work as a software engineer at Rancher Labs. We work on the open source project that extends Kubernetes. So we write a bunch of controllers and a bunch of custom resources, and I hope to share some experience with you. And I'm curious how many of you actually do write custom controllers for Kubernetes? All right, and how many of you are thinking about writing custom controllers for Kubernetes? All right, I like it already. Okay, so when do you actually start thinking about writing custom controllers? It's when you need some specific functionality that is not a part of core Kubernetes, and you don't think it's generic enough to become a part of it. Or you want to maintain your feature release lifecycle yourself. That's where you go with a custom resource and a custom controller. And yeah, every custom controller or custom feature implies a custom resource that user can view, modify, and monitor. And the controller operates on the custom resource by monitoring the resources and running the backend logic based on the resource definition, and updates the object state of the resource. And if you think about the Kubernetes ecosystem, it consists of the custom controllers, like logging, alerting, monitoring. Everything is out there that is not a part of Kubernetes is a custom controller. Now, I would really like to focus on the custom resource during this presentation. You hear a lot about custom controllers and the best practices, but how do you actually build your custom resource? Like, what are the best practices for that? So there's the little intro to the custom resource. To your user, it shouldn't matter. From the client perspective, it shouldn't matter whether the resource is the part of the Kubernetes core project or whether it's some external resource. He wants to use the kubectl, he wants to use the UI, the API, and he wants to list these resources as he would list pods, for example. On this picture, I gave an example of logs and alerts, which are like external resources controlled by external controllers. And user can just say kubectl get alert, and he would get the custom resource back. Now, what actually makes a custom resource? What are the best practices for that? I've listed some parts of the custom resource in this picture. The first one is the metadata, and the green parts on it is Kubernetes standard fields. It's going to be like a namespace if your resource is namespace. It's going to be labels, annotations, finalizers, object references, initializers if you use them. We don't in our project, but it's a useful feature. And then there is a spec. Spec is a desired set of the resource. That's a definition that user creates when he creates a custom resource. And then the status is something that controller generates based on the backend logic and updates with a set of custom fields. And there's one green field that I listed on the diagram, which is called condition. There's actually an alternative to status in Kubernetes. We're going to talk about it more during the demo. Now, as much as I like slides, I like live demos better, and I like looking at the code in IDE better. So let's build something from scratch. Let's build a Kubernetes cluster management tool, which will allow user to create Kubernetes cluster, view them using the kubectl, and we'll also give user a chance to use the kubeconfig and to connect to this newly generated cluster. Now, what are we going to show during the demo? We're going to show the client generation from scratch. Then we're going to show how to handle cluster delete update events, how to utilize the resource conditions to reflect cluster state, and how to use Finalizer to execute delete prehooks. And a little disclaimer, at Rancher, we actually built a framework to create the boilerplate for all of that. But for this presentation, I was like, no, I'm not going to use the framework. I'm just going to use whatever the regular user would use, the user who would first thinking about writing the controller for a custom resource. So, and here are the tools that I'm going to use. The Kubernetes code generation tool, which is a Kubernetes tool for generating the controllers, listers, informers for the custom resource. And then I'm going to use for the cluster provisioning itself, I'm going to use this open source RKE tool, which is a tool built by Rancher, but like any tool can be used. I just prefer to use our tools. Like, I'm sure that we're going to run into issues during the demo, and I would like to report these issues back to the team. And then here's a demo controller logic that can be found here on the GitHub. All right, demo time. So as I mentioned, we start with, first, what do you start with? You start with defining your resource. So our resource is cluster. The first two fields, type meta and object meta, is a standard Kubernetes fields. The next two fields, cluster spec and cluster status, is our specific fields. And I also define them in the same file. Here you can see it. It has, what is it? You can, yeah, I'll do it bigger. I'll make it bigger. Is it better? I would like to really keep this. I tried presentation mode, but I lose the structure of the, I use this structure and I would like to demo it. Yeah. So I forgot to mention one thing. The code generator requires you to have a specific layout for types definition. So it all starts with this PKG folder. So you create a PKG folder, and then you create an API subfolder in it. And then you create the version for your APIs. And that's where actually types.go goes. And then you also have to create this register.go file with a group name for your API. And then after you define this types.go, you actually run the update code gen script, which actually invokes the code gen functions to generate the listers, informers, and the deep copy. And now let's go back here, and actually going to do the presentation mode to make it better. Okay, here you go. So yes, the cluster status. This condition is somewhat the generic field recommended way of storing the resource state, and it's actually an array of the condition because you can have more than one controller operating the same resource, and it's better that one condition is used and set by one controller. Actually, any other controller can evaluate it, but it's better that it's only one controller that updates this field. And then I also have this observed generation field, but it's actually, there are some issues in using it if your Kubernetes version is less than 1.10 for custom resources. I'm going to note more about it later. And then once the resource is defined, you have to put some annotations on top of it in order for the code gen to generate the proper client for your resource. Right. Now, let's look at our controllers. So once the types are defined, we're going to start with the controller's logic. So in this tool, I have 4 controllers. The main one is the provisioner tool. That's controller that's going to be actually responsible for the cluster's provisioning. And there are several more. The health checker controller will actually check for the cluster health state and will update the appropriate condition. And there's also a config generator controller that is going to generate the kube config based on the cluster once it's provisioned. And there's one extra controller that is purely for the annotations updates. So let's look at the provisioner controller. Provisioner.go. I'm going to switch back to the presentation mode. So this register method, the register is the controller. I use the task queue and the cluster informer, but again, in this presentation, I'm not going to focus much on that. You can find it in the sample controller example given by Kubernetes, all the specifics about the task queue and stuff. But here, what we do, we're actually going to listen for the add and updates events on the cluster, and then we are going to invoke the sync method that will actually take care of the cluster provisioning. So this cluster handle cluster add will actually do the provisioning. Let's try it out. Let's actually look at how our resource looks like. That's our custom resource definition. So it contains, we're going to place some metadata on it. We're going to label it with AWS because the cluster is going to be provisioned on the AWS host. And this is a config file to config path to the actual cluster specification. Which is pretty simple. is just the address where your cluster is going to reside, the credentials, and the role for which node for this particular host. So the controller, worker, and etcd of the cluster that we're going to provision all going to reside on a single node. So, and now let's start our controller before we create a cluster. A little bit about my setup. I run OS X and I have Minikube. So, and I run my controller here. So what it does, first it creates CRDs, and then it registers all the controller that we just went over. And now, and it sits and listening for the cluster create event. There's no cluster yet. Let's create it. And I'm using kubectl to create it. All right. So what's going on here? So you can see the message that cluster is updated, provisioning. So the actual provisioning is going to happen here for, I think it will take a while because we download the images. The Kubernetes cluster gets deployed in the container. We download the images here. But let's just focus on this message. It says cluster is updated provisioning. Does it mean that the provisioning code is going to be invoked on every update? Because you can update multiple fields on your object. Like you can update the metadata, you can update the labels, you can update the spec. So what we really want to happen is for the provisioning logic to be invoked only when the spec field gets updated. How do we achieve that? As I use Kubernetes 1.8, unfortunately, I cannot use the observed generation and generation. But in Kubernetes 1.10, there is a generation field in the metadata that gets changed only when the spec gets updated. And as a controller, you can actually store the observed generation in the status, and you can invoke your controller if your observed generation is different from the generation in the metadata increased by Kubernetes. In my case, what I do, I just store the applied config, the cluster config that get applied, I get stored in the status. And then I check the one from the spec with the one from the status. If they're identical, there is nothing that I'm going to do. I'm just going to return nil and do nothing. Now let's check what happened. OK, so it's still going. I'm looking for the red markers like error. I don't see any errors yet, so it's a good thing. So there is something that we do in the beginning. So here I call something called initialize. In initialize method, I inject the finalizer into the object. So now, does anybody know what finalizer is for? OK, awesome, yeah. So finalizer is something that actually some construct that allows you to run the predeletion hook when your object gets removed. So like, let's say you decide that you're going to remove the cluster, and you want some logic to run before object is actually gone from the etcd database. In this case, you inject the finalizer, and Kubernetes will not remove this object from the etcd database till you run your logic until you remove this finalizer. OK, I'm going to check on our guy. Still going. OK. So nothing failing yet. Let's look at how our object looks like. All right, there is a cluster. There is no, OK, so there is some status. Does it mean that it's, oh yeah, successfully provisioned cluster, that's good. But, but I wonder, where's my, I wonder my conditions are. I think I broke something in my code. I just made this very last commit before the demo. It's always a bad idea. But what actually should happen here in the status, you should see the condition that says provisioned true. And then you should see another condition that says ready true. So the provision means that the cluster provisioner actually successfully provisioned the cluster. And ready true means that the cluster health checker actually says that the cluster is healthy and and ready to be used. Now, why do we use two conditions? Because, like, as I mentioned, it's better that the one condition is modified by a single controller. There is one more rule that we try to apply to when it comes to conditions. It's better that conditions are consistent in a way that true means good and false means bad. Because sometimes you might want to see you might see the conditions in the Kubernetes world when actually false means a good thing. It's like condition can be named like, I don't know, cluster is failing, and then false, and it means you're good. It's better to use the same construct across your conditions, so later on, if you would like to signal to your user that the cluster is good, you can actually fetch all the conditions, and based on their value, you can say whether it's good or bad without applying any custom logic. So now we've covered condition, we've covered applied spec and observed generation. Now there are a couple of standard Kubernetes fields that people tend to use very often. One is labels, and one is the annotations. When do you use one over another? So when would you use labels? So I usually use labels when my resource is meant to be queried based on a certain label, or you would like to group the resources. Like in this case, for example, my cluster is AWS, and let's say in kubectl, I would like to list all my AWS clusters. So I just do get cluster, and I get my cluster back. All right, and now where would you use annotations then? Annotations we usually use to store some kind of like sort of a metadata. Like in this case, annotations. Yeah, I don't think I said any annotation here. But what you can store in the annotation in this case, you can store, for example, the underlying Kubernetes version. There was one object that we create as we created the cluster. We created the kubeconfig. Oops, it wasn't created. Something went wrong. Let's restart it. No. Okay, I have no idea why the kubeconfig wasn't created, but I've kind of expected it. It's demo, it's meant to fail. But the kubeconfig is the resource that was meant to be created as a child resource of the cluster. So what does it mean to be the child resource? So it means that the object lifecycle can be kind of like managed indirectly by the parent resource. So it's like when you create a parent resource, you create a child resource. When your parent resource is gone, your child resource is gone. And you don't have to handle this cleanup yourself. You can actually rely on Kubernetes garbage collection in this case. Kubernetes garbage collection, like once the parent resource is removed, is going to remove all the child resources. So that's what the owner references is for. But now let's try to just list one cluster once again. Oops. Okay, so we have our finalizer. At least this was one injected. Let's just test the finalizer logic. Let's just stop the controller. I'm just going to stop it. And let's remove the cluster. All right, and let's see if the cluster was actually removed. No, it's still here, but let's look closer at the cluster. You see that although it wasn't removed, there was some deletion timestamp that was set for it. And if I start my controller back, it should look at the deletion timestamp, and based on its value, it should decide whether it needs to go ahead with a provisioning or whether it needs to go ahead with the removing. Good boy, it's removing. So what it does, it actually goes to the AWS host and it cleans up all the containers that have a Kubernetes cluster deployed. All right. Okay, so it's cleaning it up. And now the resource should be gone. Okay, so no more clusters. Yeah, removed. All right. So a little bit like reflection based on the demo. So be careful, always be careful with the update logic, because any update on the resource, whether you update the status or you update the metadata and label, triggers the resource update, and your controller should be smart enough to figure out when to run the actual update logic. So use observed generation if your Kubernetes version, for your CRDs, if your Kubernetes version is 1.10. Use some custom logic if your Kubernetes version is less than that. And also, Kubernetes 1.10 offers a new construct that I'm yet to try. They actually created a CRD for the status. So you can actually keep your status separate from your main resource. So when you change your main resource, only then you get that updates in the controller logic. When you change the status, that does not happen. I'm going to try it after the KubeCon. And then conditions. So each condition should represent a single functionality state. For multi-functionality reflection, you should consider using multiple conditions. And yes, avoid updating multiple conditions by multiple controllers. And there's rule number 3, true should mean like a good thing, and be consistent across your conditions. Then the finalizer. Use the finalizer only when you have to run the custom cleanup logic for your resource. If you're just listening on the changes to the resource and like you don't care about the cleanup, like you don't need to access the object spec after it's gone from the etcd, then you don't need the finalizer. You can just go with the regular sync logic. And then the owner references. Always try to find out whether a Kubernetes has some built-in functionality that you can invoke by placing a certain field on your object. Like use owner reference to invoke the garbage collection for your child resources. Don't run the cleanup manually. And thank you all for coming. If you have any questions, you can ask them now, or you can reach me out later on Twitter. You can just step by, and yeah.
Do you know the state of the Python support when it comes to
I don't know. We use like 100%. We use Go. I have no idea about the Python support, unfortunately. Yeah.
What does it take to build an operator?
There's a mic for questions.
Oh, yeah. Where is the mic? Is it? Oh, yeah.
Yeah, thanks a lot. Very interesting talk. So my question would be, we heard about operators, and your talk mentions controllers. So what's the difference? I think this is an operator because it builds a stateful thing. It manages stateful things.
It's the same thing. It's just two different names. I think operator is a term, invented by CoreOS, I believe, and it's basically the same thing. It's just a custom logic for for keeping state of for keeping track of the custom resources, for updating the custom resources.
Mm-hmm. And you have 4 controllers in this operator.
Yeah, I have 4 controllers in this, and they're pretty simple. Yeah.
Thanks.
Mm-hmm.
How do you deal with controller failures? Because if my controller does some stateful stuff and it crashes before communicating the change to the resource spec, the controller will be restarted and will run it again. So let's say, does my controller logic have to be idempotent? I mean,
it has to be idempotent. Like basically, you do the reconcile for your resource as you would just do it in any like regular update case. You don't rely on some previously saved information. And if something fails, we just requeue the object, and then the update will come again, and we'll rerun the logic once again.
Yeah, I guess in some cases I have to be super careful. If for example, you created a cluster outside, and if for some reason your controller needs to be restarted, you have to check if there are some outside changes you have to take into consideration, etc.
That's actually a very
This is the door to hell.
That's actually a very good question, but it's also like whether you support external update to your resource, or whether you only support the update when it comes, like, let's say user comes to kubectl, and he updates the cluster spec while your controller is down. Your controller should be able to handle cases like that. But cases like user goes to AWS and maliciously removes the Docker container, the controller won't do it. You can, potentially you can run some agent there that will report back the status, the actual status of the cluster. In that case, yes, you can do something about it. Yeah. Can you pass the mic, please?
So I saw you used Go annotations here for mapping the schema, but there's now with OpenAPI integration in the CRDs.
There are many things. I just use it for example.
Did you have an OPI spec behind the scenes that we didn't see, or did you just write it in straight Go?
No, for this one I just ran it as it was advised, like by the example in the sample controller, like Kubernetes sample controller. But we actually in Rancher we have our own framework for defining the CRDs, for building the clients for them, and for defining all this boilerplate for informers, listers, and stuff.
One more question. So the operator framework was just announced by CoreWise.
I know 2 days ago. Yeah, I would like to try.
Did you know about that before you made your talk?
What is that?
Did you know about that before?
No, I did not. I did not about it before the talk. Yeah, as I said, I think every big company come up with some sort of the framework, and it's good if it's open source. But then you just watch the adoption, like how easy it is to use, how widely it is adopted, and then you can talk about the framework popularity. And
thank you.
I think there's one more question.
So if you have multiple controllers for HA, how do you arbitrate access among them?
If it's just leader election, simple one, like just one master.
So there's only one master at a time.
Yeah. More questions? Questions? Thank you again.